Matter in Space by Emmett E., Ram D., and Braden V. Space phenomena, antimatter. Many states of matter can be found in the infinite boundaries of space, but one of the most interesting is antimatter. Antimatter consists of positrons and antiprotons. When a particle and its antimatter particle meet, they obliterate each other since they are antiparticles of each other. They disappear and their energy is converted into other particles. Very few traces of antimatter exist in our universe today, and it's near impossible to find.
Space phenomena, black holes. Another of our space phenomena are black holes. Black holes are places in space where gravity has a pull so strong that not even light can escape, hence the name black hole. Black holes directly relate to supernova, in which black holes are caused by the explosion of the star. Some black holes are thought to have been created after the Big Bang. Scientists know black holes exist because the bending of light near black holes is so significant, instruments can sense it.
Space phenomena, stars and supernovas. Stars accumulate through gases like hydrogen and helium closing together, pulsing energy, gravity pushing against its own gravity. Once fading away, the star can't hold its own mass and explodes into a supernova. Supernovas are so powerful that they can create new atomic nuclei. Supernova is the death of a star, but the birth of a new star known as a neutron star, or different phenomena known as black holes, which was explained by Ron.
States of matter in space. As we all know, matter is found everywhere in the universe because it's the building block of everything. Matter is essential for objects to be objects. There are 5 states of matter. The first state of matter is solid. A solid is when atoms are closely packed together and are not free to move around as they wish. Some planets are mostly solid, as well as asteroids. The second state of matter is liquid. A liquid has atoms that are allowed to move more freely than solids, but not as much as gases. Liquids take the shape of their container, but do not change volume. On many planets' surfaces, there are liquids, sometimes water.
States of matter continued. The third state of matter is gas. Gas has no fixed shape and no fixed volume, and its atoms move rapidly in all directions. Some planets are made up of gas, and some stars use different gases as fuel. The fourth state of matter is plasma. It often behaves like a gas, except that it can conduct electricity and is affected by magnetic fields. The fifth state of matter is a Bose-Einstein condensate. This state of matter is made by cooling atoms for far below absolute zero and then grouped. Bose-Einstein condensates are not naturally found on Earth, but some scientists speculate that high-pressure conditions around neutron stars could give rise to BEC-like gases. High densities in those extreme environments might bring particles so close together that they would act like condensates.
Bose-Einstein Condensates. Bose-Einstein Condensates, or BECs, is a state of matter where subatomic particles, or separate atoms, are cooled to nearly absolute zero and then brought together. Bose-Einstein condensates can be described by a wave function on nearly a macroscopic scale. BECs have been created aboard the International Space Station, but some suspect that areas around neutron stars might give way to BEC-like gases.
Particle behavior in space. As stars explode into supernovas, they produce shock waves in the plasma that surround them. Streams of high-energy particles are blasted out into the universe at cosmic speeds, and these are called cosmic rays. Cosmic rays also have a very slight chance of having antimatter in them, which relates back to the first topic we discussed. These supernova shock waves are some of the most powerful particle accelerators known to mankind. These shock waves produce some of the most powerful magnetic fields known to mankind.
Jobs in space, astrophysicist. A very benefiting career opportunity for those interested in space but don't want to risk their health would be an astrophysicist. Astrophysicists try to understand the universe and all of its contents. Oftentimes, astronomers and astrophysicists are confused with each other, but they have different meanings. Usually, starting to become an astrophysicist means getting a bachelor's degree in astronomy, physics, or engineering. Then, most people proceed with a master's degree, or some go straight into a PhD in astrophysics. Becoming an astrophysicist involves lots of work and can take many years. Their median annual wage was $119,730 in May of 2020.
The kids from Bluegrass Middle School.
Emmett E. Research.
Ram D. Typer.
Braden V. Design.